All right. In this video, we are going to go over the intermolecular forces, types of intermolecular forces we can expect to have in a given molecule. And then we're going to draw the diagrams to depict those types of intermolecular forces. So let's pick something that has all three types of intermolecular forces. Okay. So let's think about methanol. Okay, so if I draw the line structure of methanol, okay, CS3OH, or if you draw the line structure, it's gonna look like this. That's it. Okay. Now, if you follow the key we talked about in a previous video, we know that it's the first question we asked is this molecule polar or non-polar, right? Obviously, this molecule has to be a polar molecule. Okay, so if you draw the molecule to the correct geometry, the Lewis structure to the correct geometry, it's going to look something like this, except for I did not draw the CS3 part because it doesn't matter. Then you're going to have two bond dipole moments going towards oxygen because oxygen is more negative than hydrogen or carbon. Okay, as a result of that, there should be a net dipole moment going towards oxygen in this direction. Okay, here's the net dipole moment of this molecule. Okay, so I can get rid of the bond dipole moments. Okay, now we have a polar molecule. Therefore, we know that it's going to have dispersion and dipole-dipole. And on top of that, we have hydrogen covalently bonded to oxygen. Therefore, it is capable of hydrogen bonding interactions as well. So this molecule has all three types of intermolecular forces: dispersion, dipole-dipole, and hydrogen bonding interactions. Okay, so let's start with dispersion forces. Dispersion forces. Okay, so when it comes to dispersion forces, what we do is we draw the molecule, okay, and then we draw the electron cloud of that molecule, okay, roughly. And also we draw another molecule closer to it, the electron cloud of another molecule closer to it. Okay, it's gonna look like that. And here's our molecule. Okay, now what we do is we're gonna randomly assign partial charges. Right, so it's gonna have partial positive here, partial negative here. It's the case, these partial charges can interact. Okay, partial negative here, partial positive here. So these guys can interact. Okay, so this is how we illustrate dispersion forces. And now let's take a look at dipole forces. Okay, so this is dispersion. And when it comes to dipole forces, we know in the dipole forces, the head of one dipole interacts with the tail of the other dipole. Okay, so here's one dipole. Okay, here's the head, here's the tail, and this tail is kissed by the head of the dipole of the other molecule. Okay, so this is a dipole-dipole interaction, but we need to draw the molecule now. So oxygen has the partial negative charge, therefore the arrowhead must be by oxygen. And then here's the rest of the molecule. Same thing here. Okay, here's the rest of the molecule. Okay, so again, the most important thing is drawing two dipoles. Head of one dipole interacts with the tail of the other. Okay, so this is going to be how we depict dipole forces. Lastly, let's take a look at hydrogen bonding forces. Okay, and when it comes to hydrogen bonding forces, hydrogen atoms, a hydrogen atom is sandwiched between two highly electronegative elements such as nitrogen, oxygen, or fluorine. Okay, in this case, let's take a look at this. So we have oxygen, here's this hydrogen. If two of these molecules interact with each other, okay, then this hydrogen, if we somehow sandwich this between two oxygen atoms, we're gonna have a hydrogen bonding interaction. Okay, so that's it. Let me draw this hydrogen bonding interaction a little bit nicely. No, give me a second. Okay. Yeah, I'm gonna use 3 dots to indicate this interaction. Okay, now here are the 3 types of intermolecular forces between methanol molecules. And yeah, I hope this helped. I'll see you guys in class. Bye, everybody.